Hey everyone, welcome to my channel. So in this video I'm going to cover the solution to this question, do some live coding work, and also at the same time I'm going to follow the general steps you should follow in the coding interview when solving this problem. So first of all, let's race through this problem. You're given two non-empty linked lists representing two non-negative integers. The most significant digit comes first and each of their nodes contain a single digit. So add the two numbers and return the sum as a linked list. You may assume that the two numbers do not contain any leading zero except the number 0 itself. So this is an example. So let's see the constraints. It says the number of the nodes in each of the linked lists is in the range of 1 to 100. So the node value is between 0 to 9 and it's guaranteed the list doesn't have any leading 0. So not too much of the room to think about edge case. I think one edge case I can think of is what if one of the linked list is 0. So then we don't need to do any further computation. We just so let's say L1 is 0, then we just return L2. If L2 is 0, we just return L1. So something like that. So one thing I think that is worth to clarify is it okay for us to do the change in place for the input parameters? So let's say for the L1, if we is it okay for us to make the change in place, because potentially we need to reverse the linked list. So if it is okay, then we can potentially save some space for our solution. So having said that, the first step of the interview has finished. So the second step is for us to find a solution. So this one, not too much of the room for the algorithm part, but mostly covering the coding ability. So in general, we are going to first reverse the linked list, reverse L1 and L2, and then do some add L1 and L2 together, and then as I would say as result. And then we are going to reverse result and then return. So why do we need to reverse L1 and L2? Because they are represented as linked list, and for adding, it's something like we first need to add so for example, let's say the first example, we need to first add 3 and 4 together to get 7, and then 4 and 6, and then we have like a carry which is 1 carried here, and then 2 we plus 2 and 5 and add a carry which is 1, and we get 8 for this digit. So something like that. So that's why we need to reverse the linked list first. So having said that, the runtime is going to be something like let's say the length of L1 is n and the length of L2 is m. Then the runtime is O. I would say it is O n plus m. So space-wise, we are not, except the return value, we are not adding any extra space for the local variables. So I would say it is all of 1. So having said that, let's do some coding work. So for coding, take care about the correctness, readability, and also don't be too slow. So at first, I'm going to get a helper function, which we just call it reverse the linked list, or we just call it reverse, and we are just going to pass in the list here. I'll just have like a to-do here, and we are going to finish this function later on. So here, like I said, maybe some edge case checking. So let's say L1 dot value is equal to 0, or L2 dot value is equal to 0. So if any of them is 0, then let's say if L1 is equal to L1 dot value equal to 0. If yes, then we just return L2, otherwise we return L1. So that's the first thing I want to check. Then the other thing, that's the edge case checking. So the rest is the major logic. First of all, we are going to reverse the linked list. We are going to say call reverse L1, and then we are going to reverse L2 as well. and then we are going to add them together, so which is major logic. So we are going to have a list, which, let's say we are going to have a list node. This is the result, or we just call it sum, as equal to a new list node. All right, so and yeah, and then we are going to have a for loop. So yeah, so you're going to have a for loop here. So let's say L1. Okay, so L1 and L2. So what I'm thinking is, do we need to actually... Yeah, no, we don't need to do that. So I'm thinking about whether I need to return something for L1 and L2. Because we are doing this in place, I think we just don't need to return anything for the reverse function. So for the for loop, not something we need to start with. So L1 is not a non-pointer, and L2 is not a non-pointer. And then yeah, so pretty much it. Or maybe you can just change this to be a while loop. So while L1 is not non-pointer and L2 is not non-pointer, so we are going to have the we need to define the carry here as 0 at the very beginning. So let's say digits 1 is equal to L1. Is L1 equal to a non-pointer? If yes, then it is 0. Otherwise, it is going to be L1 dot value. So similarly, you're going to have the digit 2 as is L2 equal to a non-pointer? If yes, it's 0. Otherwise, it is L2 dot value. So that's it for the current digit. So we are going to first compute the current digit as equal to digit 1 plus digit 2 plus the carry, and then modular 10, and the carry is equal to digit 1 plus digit 2 plus carry divided by 10. And then what should we do? Okay, so it should be L1 not equal to none, L2 equals none, and okay, and carry is not equal to 0. So I'll say something like that. So we are going to have some okay, list node car node is equal to it's equal to like new list node as well. So I'm thinking actually, so what I'm thinking is maybe we don't really need to, well, yeah, so this is a current node. So the current node is equal to new node with current, and so if it is result, well, if it's something like this, and then okay, so no, so this is should be, we should define this as current node. So current node as equal to a non-pointer, so this is new node. Okay, so let's define this one. So this is the head as equal to starting as an endpointer. So the head is equal to a new list with this one, and the car node is equal to head. So in this way, we don't need to actually reverse the results finally. And then finally, we are just going to return the car. Right, we just return the head. Okay, so that's pretty much it for this one. Let's see how to reverse this linked list. So we need to reverse the list. So we are going to have the current node. This is a current node as equal to L. And also we need to have the prev node. Now dot next. So it'll be something like okay, so this is I would just call it the next node actually. So the next node is not equal to non-pointer, then we are going to have the next. So we are going to have the list node as temp as equal to next node dot next. And then we are going to have the next node dot next set as equal to current node. And then you're going to set the current node as equal to next node, and the next node is set as temp. All right, so I think that's pretty much it. Let's see. Let me do some sanity check on top of this piece of code. So let's say we have 5, 6, and 4. We are going to reverse it. So we have the current node as 5 and next node as 6. So first of all, we are going to have the temp set as 4, then 6, the next, so 6, we set the next node for 6 as equal to 5, and then we set the current node to be 6 and the next node to be 4, okay? And then we do similar things, and then until the next node becomes something empty. Alright, so I think we still need to actually return, so we still need to actually return it. So finally, we are just going to return current node. So this is new L1, this is new L2. Alright, so let's depend on this platform to help us to do some debugging. So it says digit 1 plus digit 2 plus carry. So the variable carry is already defined in the method. Okay, so that's some typo here. So the list node is okay. So the head is equal to. So the head is equal to the current node. Head is equal to, and the current node is set up as next. So let's say we have this one. We have 3 plus 4, which get us the 7, and we set this as the head. And then we have the current node set as head. And then when it comes to 6 plus 4, then we have the head as 0, and the next node set up as 7. Okay, I think it should work. Okay, so it doesn't work. So let's see why. So we have 7, 2, 4, 3. Oh, okay, so I didn't actually move the L1 out too, so that's why. So L1, if I would say if L1 is not equal to none, then L1 is equal to L1 dot next. If the L2 is not equal to a none pointer, then L2 is equal to L2 dot next. Alright, so it's still wrong answer. Let's see. So L1 not equal to none, L2 is not equal to none, the carry is not equal to 0. What so we have the current node, we have the head, we have the carry. Yeah, so carry is this new list node as with the value as the current value, and next one is current node. So maybe the head is equal to, so okay, current node is equal to head. Okay, head is equal to, well, let's say we have, if we have 3 and 4, let's see what would happen. It's something I think we didn't do right. Why are we doing that? So we have the digit and digit 1, digit 2, the current value. So this is the value and the next node. Okay, so the head is equal to the new node. So it's a new node which is essentially set up as current, and well, let me print out something. Current, let's say I just print current. It's not actually doing anything. So L1 is not equal to none, L2 is not equal to none, then we are just going, and the carry is not equal to 0. Okay, so let's see this one. Maybe it's still not doing it right. So next node is not equal to none, then it's not possible. So you're just returning the current node. So it should return, it should output something. So let's see if it has 3 and 4. That's correct. And here, well, L1 is not equal to none, L2 is not equal to none, and carry is not equal to 0. We have the, so we have, let's print out this current carry. Okay, so it's not actually printing out anything. So L1 is not equal to none for sure, L2 is not equal to none for sure. Oh, okay, so it's actually you have the carry here, so that's essentially why you're not doing it right. So I'll say if we may need to, if carry is not larger than 0, and finally we will need to have the head is equal to a new list node, the current of carry, and the current node. Yeah, so that should do the work. Let's use some other test cases. Alright, so time limit exceeded. Let's see which one is actually not working. So it seems like there is some, yeah, so it seems like there is some, okay, L1 is now equal to none, L2 is now equal to none. Okay, so this should be a dead loop. So this should be a dead loop actually. So if both L1 is equal to none, so if both are none, if L1 is equal to none, or it should be or L1 is not equal to none and L2 is not equal to none, then you're just going to, alright, so let's see some other test cases. Or maybe we just use this one. Five, 6, 4. Yes, so it seems like it's not doing it right. So we have the current node. Okay, so we have the current node. So we have the current node and the next node. So it should be, maybe it should be car node dot next is equal to a non-pointer. Then, okay, so it's wrong answer. We should have this one set up later. Okay, so now it works. Yep. Alright, so let's do a summation here. Okay, cool. So actually we have solved this problem, but we actually make use of more time than I expected, but glad we get it finally. So that's it for this coding question. If you have any question regarding the solution or regarding this piece of code, so feel free to leave some comments below. If you like this video, please help subscribe to the channel. I'll see you next time. Thanks for watching.